Hi there, guys. Let's try a couple of these chain rule examples that have product and quotient rule in them. In fact, we already did a couple of the product rule ones. I guess we'll do a few of these quotient rules and just see how you do with them. So if we look at E, if you were looking at a derivative like this, I would view the top part of this as F, the bottom as G, and you would be applying that quotient rule, F prime G minus Fg prime over G squared. So to get the derivative of capital F, the whole function, you're going to do F prime, the derivative of x is 1, the square root G you leave alone, 2x plus 3, minus, the original is F, G prime is 1/2 2x plus 3 to the minus 1/2, then times 2. The whole thing is over the bottom squared, which is just 2x plus 3. So my first term, I just have square root of 2x plus 3. The second term, I have a 1/2 and a 2 that will multiply and give me 1. Then I have x here. And then I have 2x plus 3, and it's to the minus 1/2. So that is over the square root of 2x plus 3. And that whole thing is divided by 2x plus 3. Now I will get a common denominator in the numerator. So I will multiply this first term by 2x plus 3 square root over 2x plus 3. So what I will get in the numerator here is just 2x plus 3 over the root minus x over root 2x plus 3. And that whole thing is still over 2x plus 3. You can now combine those together and get 2x plus 3 minus x over the square root of 2x plus 3 all over 2x plus 3. So we simplify the numerator. 2x plus 3 minus x is just x plus 3. As we've seen on many, many examples, this denominator can move down here with that one. So you would have square root of 2x plus 3 times 2x plus 3. Well, you see the base here. If you had root of a times a, you would call this a to the 1/2 times a to the 1, and you'd get a to the 3 over 2. I think we're going to do the same thing here. You have 2x plus 3, which is 2x plus 3 to the 1/2 power, times 2x plus 3 to the 1. And when you combine those, this denominator will then look like, so I'll rewrite this is really just x plus 3 over 2x plus 3 to the 3/2. There's positive exponents, no other radicals. You know you could rewrite that at the bottom as 2x plus 3 square root and then cubed. But that's pretty good right there. We'll leave it that way. Okay, so you've seen one that has a fraction. F looks ugly. I'll drag F down. Since we took all the room, we hogged it here in the other one. So we'll do F as well. 1 plus 2t to the 5th, 3t squared minus 5 squared. The top function we will call F. The bottom function we will call G. We'll apply our chain rule, or sorry, our quotient rule. And so F prime is going to be the derivative of this, which is something to the 5th power, so it is a chain rule. 5 bracket 1 plus 2t to the 4 times the derivative of what's inside. That whole thing is just f prime. You still need to multiply that by g. That is g minus f 1 plus 2t to the 5th. That is f. And then g prime is going to be 2 bracket 3t squared minus 5 to the 1 and then times 6t. Okay, that whole thing, don't forget, is divided by the denominator squared. 3t squared minus 5. If you're squaring it, and squared becomes 4th power. All right, so some canceling and stuff first before common factors. There is, I'll circle it in red, there is a 3t squared minus 5 here. There's 2 of them. There's 1 there, and there's 4 here. So we can kill the one of them that's a common factor, divide it out here, kill one of them here, and one of them there. And so it will become the 3t squared plus 5 is only to the 1. This 3t squared minus 5 is gone. And one of the 3t squared minus 5's in the denominator is gone. 4 became 3. Okay, so we get rid of that common factor. Now we will try and reduce some stuff and look for other common factors that are there. So we'll switch colors to green to look for common factors. Remember, there's only 2 terms. There's one term here and another term there. Those are the 2 terms. Let's get rid of this crap from the last question. So there's the 2 terms that we're going to try and common factor stuff from. So there is a 1 plus 2t here in the first term and 1 plus 2t there. And there's a pile of them. There's 4 here and 5 there, so you can take 4 of those out. 1 plus 2t to the 4th can come out as a common factor. The other thing that can come out as a common factor is a 2 can come out, and I believe that's it. So if we remove the 2 and 4 of those t's, what's left in the first term is a 5 and 3t squared minus 5, only to the 1 power. Subtract. In this one, we took 4 of these away, so that 5 becomes 1, and it leaves 1 plus 2t here. The 2 is gone. The 3t squared minus 5 was already gone, so there's still 6t left behind. And this whole thing is still divided by 3t squared minus 5 cubed. Well, it's not so bad now because we've simplified. We've hauled so many large powers out and canceled others. We're just going to multiply the 5 in, multiply the 6t in, and cram that down. So 2 bracket 1 plus 2t 4th. Then you'll get 15t squared minus 25 minus 6t minus 12p squared. And denominator remains unchanged throughout. One last line of simplification. We have, well, potentially one last line. 15t squared and minus 12t squared makes 3t squared. So 2 bracket 1 plus 2t 4, 3t squared minus 6t minus 25, and 3t squared minus 5 cubed. Okay, so that quadratic, the 3t squared minus 6t minus 25, does not simplify anymore. It doesn't factor. So that right there is your derivative. There's no more common factors. There's nothing that cancels from top bottom. That is as simple as it is going to get. All right, I'm just doing 2 of these. I thought I'd give you a couple to check out. The other ones get about the same. There's power rules and quotient rules in there. It's not perfect, but it's a start for you to give you a few and be ready to go. Good luck.